And in the second part of this event, we'll discuss regarding the role of the data and the data management for micromobility. So I give the floor to Josep Laborda, he's CEO and managing partner at Factual.
Okay, hello everyone. So thank you, Victor, for the introduction. I'm also impressed about the quality and the insights shared by the panelists in the first half of the event today. So now I'm very pleased to kickstart and fuel now a very timely next panel on micromobility and data management. So data certainly is a hot topic in mobility. We all know that, with lots of challenges and opportunities as well arising for both companies in the micromobility space as well as for cities that strive to understand how they can best accommodate these new services flourishing in our cities. So this means shared bikes and e-scooters in our case, micromobility, while making the most of the data all of these services are producing in order to develop and implement more resilient and better informed mobility policies. So the micromobility landscape, as you very well know, is extremely crowded and I would say also very fragmented, with so many companies, some of which are very well backed by VCs, by investors. There's a lot of money flowing into this sector. And all these companies are striving to provide a differential service and so gain a competitive advantage in this market, as we have heard this morning from some of important players in this micromobility market. Today, I will focus basically on new shared micromobility services. So that means, again, bikes, conventional or electric and e-scooters that are flooding our cities and that users can book and ride on the go very easily, very conveniently through an app. So, and generating lots of data along the way. So, as all of these services continue to evolve and change the urban mobility landscape of our cities, it is critical and I would say also strategic to leverage micromobility data to evaluate and understand how these new mobility services are reshaping our communities. Indeed, shared micromobility vehicles are producing a wealth of data and information that cities need to fully understand the impact of these services on everything from equity to road safety to the environment. So in other words, sustainable mobility, so that ultimately the cities are equipped with more and better tools and actionable insights to implement more informed mobility planning and management, which is particularly relevant in a mobility as a service context. Because cities did not act quickly enough, from my perspective, to set data sharing standards when ride-hailing companies arrived a decade ago. It was too early for most of the cities that were impacted by these new mobility services, the Uber and the likes I'm referring to. And because new micromobility services still are in their infancy, let's admit it, cities now have the opportunity to avoid repeating the same mistakes again and require the data that they need that will better inform their decision-making as regards mobility planning and management. So, to do so, cities will need to set clear data sharing requirements for mobility operators that identify what information they're seeking, how it will be collected, processed, shared, stored, and the quality, accuracy, the format, and the frequency of the requested data, as well as determine clear privacy guidelines for its collection, storage, and usage. So it all comes down, in a way, to something that has not yet been addressed much, and I think it's an interesting part of the discussion. It all comes down, as I said, to how mobility operators and public authorities need to cooperate and trust each other. And bless you. And I'm going to refer to this concept of trust later, where trust is basically linked to transparency on the purpose, on the use and the data minimization principles of all of data being shared between micromobility operators and public authorities. And we basically observe three differentiated schemes, all of which come with their pros and cons, of course. There's lots of shades of gray under each scheme that we're going to see, where it's ultimately up to cities to define or to decide which model suits them best. So first, micromobility operators can provide the requested data to the city's governing agency directly. And this can be done basically in two quite radically different ways, carrying, of course, different implications. Where operators do not trust public authorities for whatever reason, or are reluctant to share their data because they feel their users' privacy or their competitive advantage in the market might be somehow compromised, they perform typically data processing first in-house. They kind of aggregate data, adding them a layer of anonymization, and only then they provide a subset of data to public authorities, which might use them for auditing purposes. This is the case, for example, of the well-known service called Uber Movement, where the company releases datasets to the public in support of urban and transport planning. And to prevent user privacy issues, Uber aggregates car GPS traces into small areas and releases free data products that indicate the average travel times of Uber cars between them. Although this is certainly somewhat useful, some might as well consider this strategy rather a PR strategy, where some researchers have even pointed out the extent to which such data, so pre-processed data, is actually that helpful to support or inform any mobility strategy in the city. So overall, it is quite evident to me that Uber and all the companies, all the mobility operators are generally rather reluctant in principle to share raw data with public authorities, which is the next scheme we will analyze, where it is cities who do not trust operators or platforms. And so they mandate that operators send all the raw operational data they generate while operating their services. A remarkable initiative in this regard, designed to govern data sharing from shared micromobility service providers to cities, is the mobility data specification, very well known. That is a digital tool that helps cities to better manage transportation in the public right of way. So the MDS is an initiative to standardize communication and data sharing between cities and private micromobility providers. And this allows cities to share and validate policy digitally. That's important, enabling vehicle management and better outcomes for citizens. Plus, it provides mobility service providers with a framework that they can reuse in new markets, allowing for seamless collaboration that saves time and money. And again, this has been mentioned this morning, that we need some common frameworks for sharing data so that, you know, ultimately services are scalable and can be easily implemented across different cities. On the MSD, a lot has been said, and also concerns have been raised by major players in the market, such as, again, Uber, which have, for example, as you very well know, sued the Los Angeles Department of Transport over what the company considered to be too stringent data sharing requirements from the city. This is only one reason why the MSD is being examined by some countries in Europe, where a critical aspect is to assess compliance with the European GDPR. And here we have seen a recent initiative which is gaining momentum, led by the the TOMP working group. TOMP goes for Transport Operator Mass Provider Working Group, which is a collaborative initiative to create a standardized language for the technical communication between transport operators and mass providers within the Maas ecosystem by means of an API. And this working group have created not only an API, but what they call a city data standard mobility, which is, in a way, an alternative to the American NDS. And a compromise solution is that where all parties would trust a third party that handles all data. This can be an academic institution, for example, a university, or can be a non-profit, or could be a data analysis platform, such as Fluctuo, that we have heard this morning in the initial keynote, or others such as Vianova, Populous, Remix. There are a few in the market. Or if I may, let me also mention that we at Factual are working on a project funded by EIT Urban Mobility called Multi-Depart, where we are developing a dashboard for managing data coming from, not from micromobility, but coming from demand responsive transit services being deployed in a city. So that's one tool that we are developing these days. So of the three typical approaches to mobility data sharing, the decision which one to pursue ultimately basically comes down to how much risk and how much active intervention in terms of data processing and analysis cities are willing or are prepared to take. Now, here I want to refer to the second of the three Factual projects that I will introduce myself here today during my keynote, which this project we at Factual are coordinating. It is funded by the USPA, the European Union Agency for the Space Program, under an Horizon 2020 grant. So MOLIERE is building an open data commons for mobility services, a mobility data marketplace underpinned by blockchain technology with the goal to raise the profile, visibility, availability, and utility of mobility data, where, importantly, geolocation of either moving vehicles or end users is provided, among other systems, such as the GPS, by the European global navigation satellite system called Galileo. And we will test this platform to fuel and to demonstrate a diverse set of concrete, highly relevant mobility scenarios and use cases where geolocation data is key. So to effectively address the needs of cities, public transport authorities, mobility service providers, and end users. Through MOLIERE's approach, what we want to do is unlock mobility data silos by providing the often missing trust layer that I was referring to earlier in my presentation, by leveraging blockchain technology, which will allow to implement the much needed security, immutability, and anonymization features required for implementing a robust mobility data sharing policy, as well as develop some data monetization schemes based on smart contracts. Just to mention that our friends from IOMOB with Boycoin in the next panel are the technological partner behind the development of MOLIERE's mobility data marketplace. A remarkable recent activity of the project has been organizing a hackathon, which, by the way, was actually organized by Carnet, again, with Laia Pagès also taking part in the next panel as the moderator of the session, where participants were asked to provide innovative solutions to common urban mobility challenges, such as, in particular, reducing the friction of users trying to find the free-floating vehicle that they had previously booked, particularly in difficult, harsh urban environments, where tall buildings create the well-known canyon effect caused by signals from satellites reflecting on tall buildings. And so the determined position of the vehicles in this case is much less accurate. This, of course, generates this friction that we want to avoid and has been also mentioned earlier. And participant teams in this hackathon were given real operational data from SEAT motor sharing service in Barcelona in this case. But of course, this data could be from any micromobility operator shared through the project's mobility data marketplace or through any other mobility data marketplace. And the participant teams were challenged to develop algorithms to correct data. So multi-constellation receivers, in our case, mounted into the IoT systems of shared e-scooters, bikes, mopeds, or cars, or whatever, can leverage signals from different constellations, so GPS, Galileo, and others, and overall provide more accurate, more robust, and authenticated location data, which is extremely relevant for all urban mobility applications. And that's what the project is trying to address and to let industry players know about. So when thinking of micromobility operators, for instance, as they strive not to be commoditized and differentiate from their competitors, and again, we have heard some strategies that some important companies in this space are pursuing to differentiate from their competitors. So great efforts are being placed not only on the software side, but also on the hardware. So this means on the vehicle itself, including safety features, as we have seen, the driving experience it provides, and importantly, I would say the reliability of the fleet management system, which should provide an improved user experience. For instance, for end users to locate vehicles where they are supposed to be, and also optimize operation of the fleet for maintenance purposes or for rebalancing the fleet. So this is where using multi-constellation receivers, including Galileo, is today a cost-effective solution that pays off and that we from the MOLIERE project are promoting. Now, because shared bikes and shared e-scooters are not isolated services being offered in cities where they rather compete with many other mobility services, including public transport, sometimes under increasingly sophisticated mobility as a service offerings, and because micromobility strives to gain a significant portion of this market, let's identify how they can provide the highest added value to city planners and how such cooperation can be nurtured by the provision of increasingly different amounts of different levels of data. So indeed, data is, as you all know, of utmost importance to sustain effective Maas that maximizes public benefit, that increases public transport ridership, while establishing a level playing field for privately held mobility services to thrive. So here, I want to discuss that analogous to the widely referenced and very well known for all of you, I'm sure, 4 levels of Maas integration topology that I'm sure you have seen in dozens of presentations before. I present here an evolution of the levels of mobility management, highlighting the key contribution of mobility data in each of these increasingly sophisticated levels. So in recent years, if you go to level 1, mobility data reporting in general, many cities have achieved level 1 of mobility management by securing or even mandating access to some sort of mobility data from different private mobility operators. And this is basically, if I had to summarize, to oversee the operation of these services in the public right of way. But of course, we want to do more sophisticated things with data. So if we go to level 2 of mobility management, this is achieved when cities are able to leverage the data that they receive, in this case, from micromobility operators, not only to oversee the operation of those services where the fleets are deployed and so on, and not more than that, I would say, but also to make more informed decisions and set more effective policies. And this, again, has been addressed several times before me, ultimately contributing to alleviating well-known transport externalities that we all want to address, such as traffic congestion or climate impacts. Some examples of data-driven policies that might be implemented by cities to manage micromobility fleets include parking, as it has already been mentioned, defining geofencing areas where parking might be restricted or allowed, or where some speed limits might be applied, some trips where the definition of routes or lanes where micromobility or other types of vehicles have priority over other road users needs to be well defined, whether or not those vehicles are actually using the lanes where they are supposed to operate. Equity has already been mentioned, where cities might require or subsidize, in some case, fleet services in an area that is underserved, for example, by other means of transport, or where specific micro incentives are to be put in place, where, for instance, first or last mile trips using micromobility services are hopefully subsidized if and only such trips using micromobility would end up in a public transport hub, to stimulate, of course, public transport ridership, which is one common goal, I would say, that many stakeholders in the city environment share. Level 3 is about pricing to optimize decisions. Given that most traveler decisions are, again, has already been mentioned, decisions are largely influenced by, among other criteria, such as availability of vehicles, of course, but time and cost. Time and cost are some important drivers. Pricing is an incredibly important tool for public agencies to leverage to shape desired transportation outcomes that they desire. Level 3 mobility management is achieved when cities effectively leverage pricing strategies, including subsidies, to influence how travelers decide whether to walk, to drive, to use micromobility, or to use public transport, for example. Last year, we saw many cities overseeing shared micromobility programs, and that they have begun to implement more complex policies for pricing the public right-of-way, including, in some cases, parking fees applied, for example, to restricted parking areas, or even applying fines for non-compliance with equity policies, for not distributing the fleet where it is supposed to be, or, for example, for some users riding these vehicles in areas where they are not allowed to ride. So while setting a fair price for access to roads, to the curbs, and to on-off street parking, well, this is an important mechanism for cities to influence traveler behavior, and also important are subsidies. Public transportation services, this was all mentioned very briefly by RIDEAL, are typically heavily subsidized because they are viewed as providing a significant public utility, and that is very obvious. So in short, public transport enables cities to move more people more efficiently than would otherwise be possible if they all drove individual vehicles. That is pretty obvious. What is not that obvious is that similarly, as new private mobility services continue to expand, such as micromobility in particular, it is important for cities to determine when and where private mobility services provide real social benefit or could be incentivized to provide such social benefit. Public subsidies, in that case, should be implemented in the most transparent, cost-efficient, and targeted way, and be designed to address the key performance indicators included in each city's mobility plans. And here I want to highlight RIDEAL. You've been looking at this logo for a while. RIDEAL, you will discover it a bit more after my keynote by my colleague, Alexandra Husley. So I don't want to spoil her, but it is a very versatile software as a service platform that we at Factual have developed. That's the third project that I wanted to mention this morning. And this platform can be quite easily plugged into any existing mobility as a service or mobility service provider back office platform, and be used to design, to run, and to manage in real time micro incentives programs to stimulate usage, increased usage of, in this case, for example, that's only one use case or one application of our RIDEAL, to increase the usage of micromobility services. So Today, many cities have realized levels 1, 2, and perhaps even some sort of level 3 of mobility management through micro-incentives. But micro-incentives, are still a nascent idea, a nascent concept, which we are proposing with our RIDEAL. The most sophisticated mobility management solutions that exist today are, by and large, applied basically to micromobility services, and generally lacking other transportation modes such as ride-hailing. So this is an opportunity. And third-party mobility data analytics platforms, such as, for example, Flucto that we've seen today, can, in my perspective, deliver levels 1 to 3 mobility management solutions for cities to manage multiple shared modes, including shared bikes, scooters, mopeds, cars, you name it. But few cities have actually implemented mobility management beyond shared electric scooters, and cities are struggling to effectively implement mobility management policies to optimize across the multiple transportation modes other than micromobility. So with level 4 mobility management, when we get there, public agencies will be able to influence how travelers make transportation decisions across modes to promote and then promote societal goals, such as reducing transportation climate impacts, alleviating traffic congestion, and expanding equitable access to mobility across the city. Because again, the most profitable areas in the city where all operators want to deploy their fleets might not be the areas where the city wants actually these mobility operators to actually provide their services for equity reasons, right? So, and of course, it all comes down to the business model and to the profitability of running these services, whether or not to deploy them in given areas of the city. So to reach level 4 mobility management, cities will need access to data from the various transportation services delivered on the public right of way to make, again, data-driven decisions, including the implementation of pricing and incentives in a smart way, not in the old way it used to be, but in a more flexible, more targeted way, as we are promoting with our RIDEAL. And again, you will hear more about this solution in the panel. So level 4 mobility, and I'm closing, can be more easily achieved alongside level 4 Maas solutions. And again, that's why I want to confront the different levels of Maas integration that I showed earlier with the different levels of data integration in cities, which go, from my perspective, hand in hand. So the mechanism through which real-time information about transportation options and specifically new pricing and subsidies could be more easily delivered to a large population of travelers through one or, more likely, multiple Maas consumer-facing applications. And that is all from my side. And I'm happy to take any question that might have come in, and I guess that there are indeed some questions coming in. Thank you.